it's Ahmed Fathi, and in this video I'd like to start deriving the derivative of the matrix determinant with respect to some parameter t. Specifically, I'd like to prove that the derivative of the determinant of some matrix A with respect to some parameter t is really equal to the trace of cofactors matrix transpose multiplied by dA by dt. This is also equal to the trace of the adjugate matrix of A, or sometimes called the adjoint matrix of A, multiplied by dA by dt. So this is the adjugate matrix of A or the adjoint matrix of A, and some people do not prefer the term of the adjoint matrix and prefer to stick with the adjugate term. So this is the adjugate matrix of A. Now let's explain those terms, although you should know all of those terms from the previous video, but anyway, the trace of any matrix A is the sum of all the elements on the diagonal of this matrix A. So this is equal to the summation of I from I is equal to 1 up to I is equal to n, and of course I am talking about square matrices. So of course this right here is a scalar, and this is expected since the determinant is a scalar and this is a scalar parameter, so this derivative should be a scalar. Now what is the cofactors matrix? Remember from the determinant section, if we have a matrix A as follows, being equal to A11, A12, A13, A21, A22, A23, A31, A32, and A33, we know that the determinant of A is equal to A11 multiplied by positive 1 multiplied by the determinant of this submatrix here, A22, A23, A32, and A33. So this is this matrix that results if we remove this column and this row, right? Now this is plus A12 multiplied by negative 1 multiplied by a second determinant here. If we remove this column and this row, we will be left with A21, A23, A31, and A33. Then we have another one, A13 multiplied by positive 1 multiplied by a third determinant, which is this determinant, A21, A22. A21, A22, then A31, A32, right? This determinant. Now we say that this term right here is the cofactor of this term A11. So this is a constant that gets multiplied by this factor. So we can write this equation as being equal to A11 multiplied by C11 plus A12 multiplied by this. We say that this is equal to the cofactor of A12 C12 plus A13 C13. So those are the cofactors and those are scalars. Of course, as you know, you can expand the determinant using any row or any column, and for every different factor you have a different cofactor, and in general we combine all those cofactors inside a matrix called the cofactors matrix, having here C11, C12, C13, C21, C22, C23, then C31, C32, and C33. So this is the cofactors matrix, and it is equal to the adjugate matrix of A transpose. So you can think of this as the definition of the adjugate matrix of A. Okay, we now need to prove this result. I'll prove this in two parts. First, I need to prove one lemma stating that the trace of A transpose B is equal to the summation from I equals 1 to n, I equals 1 to n of Aij multiplied by Bij. This is a lemma or an equality that will be very useful in the next video, so let's try to prove this. Suppose you have a matrix A, and so A transpose will be equal to, here I have A11, A12 because it is transposed, A13 for the 3×3 case. Here I have A21, A31, A22, then A23, A32, and A3, 3. Now A transpose multiplied by B, A transpose multiplied by B for any matrix A and B. Here we have B, which is B11, B12, B13, B21, B22, B23, then B31, B32, and B33. Now let's do this multiplication. We will find out that this will produce a matrix here. Here I'll have this row multiplied by this column, which is equal to sigma AK1 multiplied by BK1, right? Now here I have AK1 sigma again multiplied by BK2. And the last one here in the first row will be a sigma over K again, sigma over K here of AK1 multiplied by BK3. And of course you can continue if you had higher dimensions if you want. Now the term right here will be equal to sigma AK2 BK1, sigma over K again, AK2 BK2, then sigma over K, AK2 BK3. Finally, here for the last row, I can just remove those. So let's remove this and let's remove this. Here I have another sigma over K of AK3 BK1, sigma over K, AK3 BK2, and sigma over K, AK3 BK3. So this is equal to A transpose B. This is A transpose B. Okay, now I want the trace of A transpose B. So the trace of this is the summation of the elements on the diagonal. So the trace of A transpose B is really equal to sigma over K AK1 BK1 plus another sigma here of AK2 BK2 plus a third sigma here AK3 BK3. Now it is clear that we can combine those summations into a double summation sign, and here we can have R is equal to 1 up to N, and here we can have K equal to 1 up to N of AKR BKR, right? So here R is equal to 1, here R is equal to 2, and here R is equal to 3. Now we can change the variable names as we want, so the trace of A transpose B is equal to two summations. Here I can have I equal to 1 up to N, J equal to 1 up to N of AIJ multiplied by BIJ.